I'd like to introduce now Ramzi Jaber, co-founder of eConstruct and Visualizing Impact, who's going to be talking to us about building the office of the future. It's my pleasure to welcome you, Ramzi.
Hi, everybody. How are you guys doing? I will be talking about last mile engineering in a bit. So here in this presentation, we'll be talking about three things. One is Office of the Future. It's the first 3D printed concrete building office in the region. I'll be talking about a project that should have been 3D printed, but it wasn't, and in particular, and about a 6-axis robotic arm that we actually have here in the UAE. I thought of asking how many people have not heard of 3D concrete printing, but it might be redundant. How many people haven't heard of 3D printing of concrete? Okay, everybody has, that's good. It makes my job easier. So I'll just give the basics. 3D printing of concrete is actually similar to 3D printing of resin or plastic. You slice it, you get a print path. However, there's a few differences. There's two main philosophies of 3D printing of concrete. The first one's called layered extrusion, where they print filament by filament, so line by line, that goes up vertically. And the second is you have a bed of sand and you print the actual binder, the glue. So the glue actually holds the sand together. I did this kind of industry players map a few years ago. Most people are leaning towards the layered extrusion type. As you can see, several people do 3D printing off-site, some are doing on-site, some use a robotic arm, some use a gantry type. This was done by, the source should have been there. This was done by Khoshnevi. He's the academic father of 3D printing of concrete. He's actually based in LA. This is Enrico Dini. He told me this should have been here sometime this year. They're partnering up with Acciona, it's a Spanish company, where the 3D printing is done inside the gantry system. This is a French technology. It's called X3. It's obviously accelerated. This is printing a desk. This is a Dutch startup. It's called Cybe. This printer can actually move. And now we talk about other types of 3D printing where it's not the actual concrete, but here you're printing the formwork. So at MIT, I had to show a slide of MIT since we're in EmTech, but this one they're printing the foamwork. So this is foam, and then they pour the concrete inside. Branch Technology, they print here the reinforcement. This is ABS plastic reinforced with carbon fiber. They print the plastic, and then they shoot the concrete on it. It's shotcrete, so that's the kind of technology. This is a 7-axis robotic arm. This is a rendition. This is also Khoshnevi from Contour Crafting. Imagining you can potentially do skyscrapers with this. That's not it. I just came from Singapore. I had a meeting with Professor Kong. He's an expert in robotics, not actual concrete. And he has something called swarm printing, where you can 2 or more robots printing concrete at the same time. His latest thing actually was printing concrete while the robot is moving, which mathematically is quite difficult, but he's managed being able to do it. The theme of this conference, and I've been as with 3D printed concrete, is invention. And for the past year or so, I've actually been thinking about mass adoption. What does it mean to go from invention to adoption? And it's complicated. Whether it's government regulation, is it incentives, is it laws, is it a investment, or is it private, private sector? As anybody of you knows, I love data. I'm really passionate about data. So I put some things along. I looked at the adoption of the car and the phone. They were invented in the early 1900s. It took 85 years for it to be mass adopted. The fridge took around 35 years to be adopted. It's a pretty steep curve here. The personal computer took around 12 years to be adopted. The dishwasher, however, it was invented around the same time as the fridge. Yet it languished for 30, 40 years before it actually increased. I can tell you the story later, but actually the woman who invented the dishwasher, her company is called KitchenAid. I'm sure you've heard of it. As you can see, every invention has its own unique path to mass adoption, and it's actually quite unique for each one. But there are some universal truths or sort of reasons why things are mass adopted. And one of them is the last mile engineering or last mile design. Last mile, actually today at some of the conference was using this technology. Last mile it was originally in the telecoms industry. They would build thousands and thousands of kilometers from one end of the country to the other end. But then when they enter a city, to reach the last home was the most expensive and the most difficult. So they called this last mile, and it was actually the shipping industry, the logistics was under them, also use this principle. We're using it here in engineering. So I'm going to talk about later on, I'm going to talk about the last mile when it comes to 3D printing of concrete. But before I talk about the Office of the Future, I'm going to talk about this one project that should have been 3D printed. This is a project called 1000 Museum. It's in Miami. It was designed by the late Zaha Hadid. The penthouse is maybe the 9th most expensive property in the world. And obviously, as you can know, it has incredibly specific type of architecture. One facet of the architecture is called the exoskeleton. This exoskeleton is the thing that's holding up the entire building, and it's structural. What that means is it's actually holding up the forces. And as you can see, these are not straight columns. Here, all the columns are straight. These are curved, they bifurcate, they rejoin, and they go back. What that means is that every single column on every single floor in every single room is unique. 5,000 columns. This would have made it really, really unique, really useful for it to have been 3D printed. I'm telling you, the Doka, it's a former company, they originally suggested a conventional way of doing it, incredibly complex, 7-step process. I won't go into the engineering of it, but you can come to me later and ask them about it. And it would have been really expensive. So one of the solutions they came up with was permanent formwork that is glass reinforced. Glass reinforced concrete actually was invented in the 40s, but wasn't adopted until the 80s when they added zirconia and to make alkali resistant glass fiber. I'll just quickly show what that looks like, a little bit, just 10-second video with some. So there's some noise. So these panels that were created was actually fabricated here in the UAE and then shipped all the way to Miami in shipping containers. Because the projects are incredibly complex, we use parametric tools, visual programming tools, to actually take it from the model to the actual physical product. We had to break down the building into all the various elements to be able to do that. And actually tested it here and then sent it. There's a mental block when they talk about invention. Usually when somebody says, oh, 3D printing is too expensive, or an invention is too expensive. Actually, the cost of an invention per unit rate is usually more expensive, but as a system, it can be much more cost effective if designed well. Now I'll be talking about Office of the Future. I think, how many people have not heard of Office of the Future? How many people have? I think all of you have heard of it. It's the first 3D printed is concrete office in the world. What we did the structural design. We managed the project, and I'll talk a little bit about it. The concept was that both the vertical and the horizontal element was 3D printed, which is actually incredibly difficult in today's world because you have to include steel in the actual concrete. 3D printing of steel exists, 3D printing of concrete exists, 3D printing of both is still not there yet. So we had to actually come up with different ways to actually fix that problem. One of the ways was to overlay the steel as the robot was printing at the same time. In hindsight, if we're going to do more 3D printing of houses, which we will, we won't do it this way, and I'll explain later how we would do it. We did a lot of testing as well. We said, should we do it in 2 planes or should we do it in 1 plane? In the end, we chose 1 plane in terms of the steel reinforcement to make sure that the bonding between the layers actually work well. What we did was also we manufactured the steel cages, the steel trusses, and then shipped them over to the printer. The printer was actually in China at the time. A Chinese printer called Winson was chosen. And here's some of the analytical models. Here's a 3D printed cassette. And because this was the first time that there was a 3D printing of concrete, we didn't know how this would actually work in real life. Like how would the 3D printed respond to the forces? So what we did is we actually tested full-scale testing. So this, as you can see here, we put displacement gauges and actually measured the displacement as you're loading it. We actually tested it to failure. With the results, we went back to the drawing board and we used the results and redesigned the actual building. And here, this is the final design. And also what we did is that we actually used post-tension. So it means we put the pieces together, we put steel cables and tensioned it to hold the elements all together. And so this is what it looks like here as well. So when we went to the construction site, people were like, contractors were like, I don't know how to use this. How do we work together? So we actually developed a visual guide so that to bring people and to say, this is how you actually transport it, erect it, put post-tension. So we use very, very visual techniques for everybody to use this. And then these are just some photos of the site, which I will just flip through quickly. And here are some photos of the installation as well that was put in later. And that was it. So as a team, one thing I was saying is, so after the experience of actually, structurally designing it and actually, helping with the construction, I'm on the board of this new venture. It's called Concreative. This is actually in the UAE. It's printing. It's a 6-axis robotic arm that prints concrete. I should maybe organize a tour for people to come visit. If anybody's interested in seeing this, do let me know. One of these projects actually going to be done. It's called the Green Wall. As a company, we're doing 3 things. One is as a team, we're on the ACI committee, the American Concrete Institute's Committee for 3D Printing of Concrete. We're also our building physics and MEP design, who are designing net zero energy buildings, are thinking about, they're envisioning how to incorporate mechanical and electrical serving in 3D printing of concrete, how it can be much more space efficient. This hasn't been done, but should be. And the third is material. We're actually testing, creating our own type of concrete called ultra-high performance concrete, using local materials, using desert sand with steel fiber and glass fiber, so that we don't import the material from abroad. And the future of structural engineering is called topology optimization, where we only use the material that's needed for the forces that go into it. So as you can see here, those two configuration actually hold up the same amount of forces. And this is one project that's in ETH. And there is a philosophy in architecture called structural determinism, which means that the architecture actually responds to the forces to it. So here you can see on the right, the loads that go onto the circle actually determine the shape of it. And that's it. Thank you very much.